March forward. Haha, get it? The steepest paved road in the world is Baldwin Street in Dundee, New Zealand. It runs up a hill for a quarter of a mile at an angle of 20.8 degrees with the valley floor. Can you imagine riding a bicycle up this hill? So what I've done is I've put a triangle that could represent this situation. How much higher are you at the top of the hill than at the bottom? The angle is 20.8 degrees. The length of the road is 1/4 of a mile. And what we're going to do is we are going to work through today SOHCAHTOA and beyond. It's going to be really exciting. So we're going to use trigonometric ratios. The word trigonometry comes from the Greek words for triangle and measure. So for the New Zealand road problem, the ratio of the length of the leg opposite the 20.8 degrees to the length of the hypotenuse will be the same in every similar triangle. So here's what I want to refresh your memory from geometry. Is the SO stands for the sine of some angle is equal to the opposite of that angle over the hypotenuse. And let me have you write this down. This is a Greek letter called theta. And because the Greeks are often attributed with discovering trigonometry, we use a lot of Greek letters. So theta, beta, those are common. So when I say sine theta, that's the angle. The CAH stands for cosine theta. It's adjacent to that angle over the hypotenuse. The TOA stands for the tangent of that angle is the opposite of the angle over the adjacent of the angle. I'm going to pause here a moment to let you catch up to me and to talk about a couple of little things. I see this every single year that I teach this. I have students who omit the angle. On a quiz or a test or a skills check, I am going to deduct points. Not because I'm a mean teacher, it's because it makes no sense if you write tangent of nothing. Because you need the opposite of an angle, and in a triangle there are 3 angles. So I don't know which one you're coming from to make it the opposite of. So it is a requirement to have an angle inside your trig function. So let me write something else down here. SIN is an abbreviation for the trig word SINE. And we pronounce this like sign, like it's a stop sign. COS is an abbreviation for the word cosine. So it's like, I'm going to cosign your loan. Tan is an abbreviation for tangent. Tangent. All right, so you should remember from geometry, SOHCAHTOA. So we're going to start building our foundation from what you learned last year, and then I'm very quickly going to take us up to Algebra 2 today. So it's going to be fun. So in example 1, it says, find the unknown side length x. So here's what I do. I identify which sides I'm given, and then I look at SOHCAHTOA to determine which trig function I need to use. Well, x is which side of this triangle? Is it opposite, adjacent, or hypotenuse? It's the hypotenuse. Okay, coming from the given angle, angle B is given to be 43 degrees. Then 20 would be what coming from angle B? Is it opposite of B or adjacent? It's adjacent, right? That's adjacent. So what I strongly recommend that you do on your homework tonight, and I'll tell you, you're going to get partway on it. We're going to spend 2 nights on the worksheet. But I'll give you which problems to do tonight, and then tomorrow you'll finish it. But I strongly recommend on each page, at the tippy top of a page, write SOHCAHTOA down, and then just use it the whole page. So I have adjacent and hypotenuse. Which of the 3 trig functions, sine, cosine, or tangent, should I use? Good job. I want to use cosine. Now, we say cosine, okay, don't ever say cos, say cosine, but we do abbreviate it. Cosine of 43 degrees is adjacent over hypotenuse. Okay, cosine 43 degrees, because we know that, equals 20 over x. Well, guess what? I can change cosine 43 degrees to cosine 43 degrees over 1, and I have created what? A proportion, right? How do we solve a proportion? Cross multiply. If you have a calculator with you, go ahead and grab it. The ones that I have in the tray, I need to remind you. I have a Post-it note there. The first 5 are other students in my slot. You may never borrow those. Those are somebody else's. The back 5 in slot 6 through 10 are mine. You may borrow them. Put a cell phone in, and you can use the back 5. The front 5, I never allow you to borrow another student, because I cannot assure the safety of it. Here's what I need you to do before we get going too far is check the mode if you are on a graphing calculator. On the TI Inspires, you should be able to see in the upper right-hand corner on a blank page whether it says DEG or RAD. If yours is DEG, you're golden. Is there anybody in the upper right-hand corner on the page that says RAD? Okay, if yours says RAD, let me show you how you fix this. Press your on button. Okay, press your on button, and you should see 2 columns. The one that says Documents, number 5 says Settings. Do you see that? Press number 5, and then you should see something like Document Settings. Go there. One more time. You're on a blank calculator page. Hit the on button, the home button. Then go down to Settings, hit Document Settings, and do you see yours probably says Angle Radians. So go to Angle, change it to degrees. Now you're not done, okay? I need to tell you something very specific. Otherwise, it's not really changing it. Change it to a degree, but then along the bottom, you have to click on Make Default and hit Enter on Make Default. Then get out of there, and then we'll try this together. So now, tap all the way down and hit, make sure it's highlighted on Make Default and hit Enter. Then it should say, like, you did it. Does that make sense? I'll come help you. So here, then I need to divide both sides by cosine 43 degrees. If you are in the correct mode, you should be getting something close to 27.35. Okay. Okay. Anybody else not getting this? Can I help you? Oh, sorry. Oh, hurry. Okay. Thank you for asking me that. I forgot to tell you, in case you didn't know left side of the TI Inspired, you see a button beside 7 that says trig. Press that, and that's your cosine, and your sine, and your tangent, and the other one. So let's just say okay. Okay, try it now and see if you get this number. All right, anybody else need help? Okay, this is awesome. And again, example 1 is from geometry. We did this back in geometry. Is this coming back to you? SOHCAHTOA. All right, awesome. Okay, now we're ready for algebra 2. Okay, that was geometry. So now, on the left side here, I have the SOHCAHTOA. That's what we know. So now, I'm ready to take us to algebra 2. Each trig function has what we call a reciprocal function. So let me explain this. This stands for cosecant. Okay? CSC, we never say CSE, we read it as cosecant A. And if the sine of angle A is opposite over hypotenuse, cosecant is hypotenuse over opposite. It's the reciprocal of the sine function. So this is new for you. So sine and cosecant are what we call reciprocal. If I have A over C, then cosecant is C over A. Cosine, its reciprocal is secant. So if cosine is ca, adjacent over hypotenuse, secant is hypotenuse over adjacent. Now the bummer is, I don't get to name these, all right? So the reciprocal of sine starts with a C. The reciprocal of cosine starts with an S. Why they couldn't have been CC and SS? I don't know. I didn't get to choose. Then the reciprocal of tangent is cotangent. Now that would make sense. Okay? So if tangent is TOA, cotangent is adjacent over opposite. So what you're going to need to do is work on remembering these. Okay, these are 3 new ones. Example 2. It says find the value of the trig function. I'm not trying to find the angle. You see that? And so part of what we have to navigate is directions. So in number 1, it says cosecant theta. So I'm going to show you how I do it, and however you want to work it out is fine, as long as you're consistently getting the right answers. I remember that the sine is so. The sine of theta, and here's theta. Your perspective, what angle you're coming from, makes a difference. So the opposite is 3, and the hypotenuse is 5. So here's what I do with my new reciprocal. I go to their original, and then I flip it. So sine of theta is 3 over 5, so cosecant theta is 5 over 3. Does that make sense? Sine and cosecant are reciprocal. So anytime I see cosecant, I do sine and I flip it. Now let's look at number 2. The sine of theta is so, but I've got to look at where is my angle. Which side is opposite theta? 8. What's the hypotenuse? 10. I'd like you to write something down. We reduce all fractions. We reduce all fractions. So sine theta would reduce to what fraction? 4 over 5. All right, I'm going to pause a moment, give you about a minute or 2, head start, and I want you to do 3 through 6. Use SOHCAHTOA And if it's a reciprocal, do its original and flip it. Make sure final answers are reduced, okay? So make sure you're always determining where theta is located, and then opposite and adjacent will change where, depending on where theta is, but the hypotenuse never changes. That's always across from the right angle. All right, I'm going to go ahead and start. Tangent is TOA. So I look at where my angle is, and the tangent of theta is the opposite over the adjacent. So 5 goes into those, and I would get 4/3. Number 4, tangent, again, is TOA. From theta, that's 24/7. That one does not reduce, so that's my final answer. Number 5, sine is so. So the sine of theta is the opposite over the hypotenuse. Which one is the hypotenuse? What number? 21. Oh, that will reduce. That's 2/3. All right, cotangent. That is going to be the reciprocal of tangent. So I'm going to start with what I know. Tangent, TOA, is opposite over adjacent. So cotangent is 6/8. And then I'll reduce it to 3/4. All right, does that make sense? These are my 3 new ones. All right, while we're here in the right triangles, we're going to take a look at something. The measures of the 2 acute angles in a right triangle always add up to 90, because what's the sum of 3 angles in a right triangle? 180, and if one of them's 90, the other 2 have to add up to 90. You may recall from geometry that 2 angles that add up to 90 are called complements, or complementary angles. If I call one of those 2 angles x, and they're complementary, what's the other one then, in terms of x? Yeah, 90 minus x. You got it. Okay, so I want you to take a look at the diagram, and then we're only going to look at these 4 because they go together. You see the sine of angle A is A over B. Now, A and B are complementary angles. Okay, angle A and angle B are complementary angles. So do you notice that the sine of angle A is equal to the cosine of angle B, right? Because they're both A over C. So here's kind of my big idea. If I have the sine of an angle, it's equal to the cosine of the complement. So the sine of theta is equal to cosine 90 degrees minus theta. Likewise, if I have the cosine of theta, it equals the sine of its complement. That's going to be something we're going to put in our back pockets and use a little later. All right, so far we've used SOHCAHTOA and their new reciprocals to just find the ratio of the trig function. Now we're going to find the ratio of the trig function to help us actually find an angle. So if you look at example 3 and it says I want to find angle theta, and I've given you a hint. If we could find the cosine of theta, so 15 is the hypotenuse, and 12 is the adjacent. So I'm going to put 12 over 15. So 3 goes into both of those. So cosine theta equals 4/5. Now I'm going to make a beautiful connection to something we did earlier this year. Is you remember in my math tool belt I had a light switch. Does anybody remember what math concept we used the light switch for? Oh, please, please. Somebody knows, right? What was the light switch for? We were switching something. And why do you do it? Anyone? Never watched those either. That's from my day. That was a new movie back in my day. Inverses, okay? Inverses. So what I need to do is remember addition and subtraction are inverses, multiplication and division are inverses. Well, we actually have the inverse of each of the trig functions. So I want you to go ahead and write down exactly what you see, and then I'll explain it here. And you're going to need a calculator in order to do this, otherwise you can't do it. All right, so look, the inverse cosine and cosine, since they're inverses, they cancel each other. Like 3 minus 3, they cancel each other. So inverse cosine and cosine are going to cancel each other, and I'm going to get theta equals the inverse cosine of 4/5. Well, on the TI Inspire, when you hit that trig button, you will see the inverses underneath the 6 trig functions. So what I want you to do is use your calculator and hit inverse cosine 4/5. I got theta was 36.9 degrees. Unless I say how to round, you can round 1 or 2 decimals is always okay. 1 or 2. All right, are you getting it on your calculators? Are we getting it with the buttons? All right, awesome. Let's try another one. If I want to find angle theta, I have the opposite and the adjacent, so I gave you a hint and said that's TOA. So that's 18 over 9. So I have tangent theta is 2. So I need to undo the tangent function. So I have to take the inverse tangent to both sides. Okay, I'm trying to undo the tangent function, and the only way to undo it is an inverse tangent. So then the inverse tangent of tangent is theta. And then the only way to do this problem is on the calculator. So I got 63.4 degrees. right, then the last topic is we're going to tie this together. Okay, we're going to tie it together with what we did yesterday. You remember our two special right triangles. In a 45-45 right triangle, the two legs are 1 and 1, and the hypotenuse is square root 2. So you need to know that. You can always do Pythagorean theorem and do 1 squared plus 1 squared to find that. Okay, but after time, you just should remember it. In a 30-60 right triangle, I could let across from 30 be 1, the hypotenuse is double, and across from 60 is 1 times square root 3. So watch my table here. And I'm going to do the first row off to the side so you can see where the numbers came from. But the sine of 30 degrees is opposite over hypotenuse. So sine 30 is 1/2. The sine of 60, now I'm coming from 60, is going to be radical 3 over 2. And then the sine of 45, it doesn't matter which one you come from, that's 1 over the square root of 2. So I'm going to rationalize that and get square root 2 over 2. Eventually, we're going to want to remember this table. Okay? Eventually, we're going to want to remember this, but we can always come up with them. All right, without using a calculator, so these next two do not touch a calculator. And I want to show you how we can, in fact, do these without a calculator. If you know your two special right triangles. So watch number 1. It says find the value of theta. Okay, this is super cool how this connects. So watch this. From theta, 4 is the adjacent, and the 8 is the hypotenuse. And remember what I told you? I said on your homework, you're going to want to write SOHCAHTOA out at the top of a page and then use it, use it, use it. So that is even true in our notes. So what trig function would I use for adjacent and hypotenuse? Cosine. So watch what we're going to write. We're going to write down cosine theta is 4 over 8. Now we're not touching the calculator, so watch this. The cosine of theta is 1 over 2. Now let me show you how we can figure out what theta is without touching a calculator. Because I will have in your future some no calculator, like not even scientific calculator allowed problems on a quiz or a skills check of some sort. So look, cosine, I should recognize getting the 1/2 is in a 30-60 right triangle. So I'm coming back to my 30-60, and where would you get adjacent over hypotenuse is 1/2? Well, that's from 60 degrees. So without ever touching a calculator, theta is 60 degrees. All right, number 2. Now I have an angle of 30. I have the opposite, and I have the hypotenuse. Which trig function should I use? Out of SOHCAHTOA, which one? Is tangent OH? No, it's sine, right? So we're going to say the sine of 30 degrees equals 10.8 over x. And again, you might be thinking, how am I supposed to do that without a calculator? Well, I'm so glad you asked. Because if I look at a 30-60 special right triangle, let's go look at it. What is the sine of 30? 1 half. So that's going to be 1 over 2 equals 10.8 over x. What's it called when you have one fraction equals one fraction? That's a proportion. How do we solve a proportion? Cross multiply. So that's x equals 2 times 10.8. And guess what? I really will live if I do that without a calculator. And I get 21.6.